Hello, we present our proposal for the Extreme Terrain Quadruped, or ET Quad, for the 2022 NASA Big Idea Challenge, which will support the upcoming Artemis missions and the goal of establishing a sustained human presence on the moon. We are a team of 6 graduate students and 8 undergraduate students from multiple departments at the FAMU-FSU College of Engineering. We have expertise in biologically inspired and legged robotics, dynamics, and controls. The lunar surface consists of rugged terrain with craters, steep slopes, and deep regolith, all of which make navigation difficult. To address these difficulties, we propose a highly capable, multimodal legged robot, ET Quad, designed for walking on uneven terrain, climbing steep slopes, and trudging through regolith. This robot will be able to complete missions that are dangerous or impossible for traditional wheeled rovers, which have previously had difficulty negotiating steep slopes and have sunk into deep regolith on planetary missions. These difficulties have led NASA to consider various legged robotic platforms, such as RoboSimian, a dexterous robot for rugged terrain and complex tasks, Llama, a fast-moving quadruped, and Lemur, a climbing robot for vertical surfaces. Like NASA, the FAMU-FSU College of Engineering has extensive experience with legged robots, including dynamic climbers, fast runners, and multimodal robots for running and climbing. Notably, researchers at the college developed the world's fastest dynamic climbing robot, and collaborated with JPL to develop the Llama robot. We also participated in the development of Minotaur, a dynamic quadruped with sensing and autonomy capabilities. The development of ET Quad will synthesize the inherent capabilities of legged robotic platforms with our experience in multiple modes of robotic locomotion to build a robot that integrates dynamic walking, climbing, and trudging through regolith into a single platform fit for various exploration and science missions on the surface of the moon. As we develop ET Quad, we will address 2 basic challenges present on the moon: steep slopes and deep regolith. Certain animals, such as geckos, climb steep slopes with directionally adhesive feet that engage the climbing surface when pulling and release when pushing. This concept is instantiated with microspine arrays, such as those used on Lemur and climbing robots designed by the FAMU-FSU College of Engineering. Our preliminary simulations and experiments have identified certain gaits and strategies that can be employed by legged robots to move through resistive media such as water, snow, or regolith. These gaits can be used by ET Quad to continue to make forward progress even after the robot has sunk into deep regolith when exploring craters. Our initial prototype for ET Quad is already capable of standing and walking, with climbing coming soon. As part of the NASA Big Idea Challenge, we will use our rapid prototyping and robot testing facilities to further develop the robot's capabilities and improve the hardware design to make it fit to face the challenges of lunar exploration. Special thanks to our collaborators at JPL, the Army Research Lab, to the University of Central Florida for the use of their regolith testing facility, our faculty advisors, and you for your consideration.